So you might be asking yourself, well, if step one was that easy, could all the steps be that easy? And well, if you've been paying attention, I mean, I believe so, but I'm a little biased. I mean, I'm teaching the lesson after all. But step two is something we've already done. It's just solving for your reactionary forces. Okay, we got a couple. We got a reactionary force at our roller here at joint C, and so it only has one, and it's perpendicular to your plane or whatever. So we'll just call that reactionary force at joint C in the y direction. And then we've got a couple over here at our pin. Well, okay, we've got a reactionary force at joint A in the y direction, or good old ray. And then we've got a reactionary force here at joint A in the x direction, or good old rax. And so these are the three forces that we need to solve for. So I'll go ahead and write them out here. We need to know what rax is. Well, rax equals question mark. And then ray, we're solving for ray as well, so that equals question mark. And we're going to go ahead and pick the right color here. We're going to solve for Ricky over here, and that is also unknown. It should be pretty easy to solve, hopefully. Let's go ahead and start solving. So we can start with, what are the sum of all forces in the x direction? Okay, so let's ask ourselves that question. What is the sum of all forces in the x direction? We know it has to equal 0, otherwise this bridge would be moving side to side, so everything has to be canceled out. Well, what forces are in the x direction on the outside of this truss? Well, there's only one force acting in the x direction, and that's rax. So therefore, rax equals 0 pounds of force, because it has to add up to 0 to be moving. So that was really easy. Now we can move on to our y component. So we'll say, okay, the same thing. We'll say the sum of all forces in the y direction equals 0. Well, what is that? Well, we got Ray, good old Ray, and we will add that to Ricky. Okay, so we'll add that to Ricky. But if you notice, both of these forces are going up. So they need to be canceled out by something else. What other forces are acting in the y direction on this? Well, that's this force at joint D, and that's just 500 pounds. So we'll add 500 pounds to the system. And we know that these three forces will add up to 500. Now, I don't want you to get wrapped up in what's positive and what's negative, what's going up and what's going down. Instead, just follow this rule. Set your upward forces equal to your downward forces. For that matter, in x, you set your leftward forces equal to your rightward forces, and follow suit with any kind of question with vector forces. Okay, so we'll say Ray plus Ricky. So let me get color coded here. But our upward forces are equal to our downward force, so these will all add up to 500 pounds. Okay, so I know this has to be true because they all have to cancel out. But you might be looking at this and thinking to yourself, well, where do we go from here? We don't have a lot to go on. We've got two reactionary forces that are variables. How do we solve? And so to solve for this, as we've seen in the past, we have to use what we call the sum of all moments. We know the sum of all moments also has to equal 0. Well, how many moments are in this system? First off, we've got a moment at joint C. We've got a force at joint C and a distance from our pin. That would be a moment. So I'm going to follow my force. The force is going upward, and then I'm going to move it towards my pin, so up and to the left. That will be moment C. And then I'm also going to follow my force here at D. It has a distance from our pin, and it has a force, so it's going to continue down and then towards our pin. What's down to the left? Well, that's moment D. And there's no other force. Or there's no other moment, I should say. There's another force. There's Ray. But that has no distance from the pin. It's 0 distance, so that's not a moment. And B has a distance from the pin, but it has no force. There's no moment at B either. So this is, that becomes very, very simple. We say, well, sum of all moments equals 0. Well, that's just, well, moment C plus moment D. And then we look, well, we got to say, well, our clockwise moments are going to be equal to our counterclockwise moments. Well, as you can see, moment C is our counterclockwise moment. Okay, so counterclockwise. And then moment D is our clockwise moment. Okay, we can clearly see that's going to be going clockwise here. We will set our clockwise moments equal to our, instead of looking at, well, counterclockwise is positive, clockwise is negative, and setting them this way, saying one's positive, one's negative, that I find is kind of confusing. So just like before, we set our upward forces equal to our downward forces. I'm going to set my counterclockwise moments, which is just one, moment C, equal to our counterclockwise moments, moment D. And we know what these things are. We know that moment C is a force times a distance. So we might not know the force at moment C, but we do know that it will be equal to Ricky. And that's kind of the whole point here, that we're going to solve for that variable. And we're going to multiply that by the distance at moment C, which is the distance from our pin is 7 feet and then 3 feet more. So 10 feet. So Ricky times 10 feet equals moment D. Well, what is that? Well, we got a force at moment D as well. Okay, well, that's 500 pounds. And it has a distance as well. Well, what is that? What is that distance? Well, the distance from our pin from force D is just 3 feet. We plug that in, we say 3 feet. And that's very simple. 500 pounds times 3 feet is 1,500 foot-pounds. That is our moment at joint D. And we'll set that equal to the moment at C, which we said a second ago was Ricky times 10 feet. So we'll say times, and then let me get the right color here, keep it color-coded, times 10 feet. And we can just divide by 10 feet on both sides to solve for Ricky. Well, we can see 10 feet cancels out over here, and feet cancels out over here, and 1,500 divided by 10, well, what does that become? We get Ricky equals 1,500 divided by 10 is just 150 pounds. And then we can just plug that in right over here. And if Ray and Ricky add up to 500, we could say, well, Ray plus 150 pounds equals 500 pounds. And hopefully you can do this just in your head, but we'll go ahead and do the algebra just to see it done. To solve for Ray, we just got to subtract 150 pounds on both sides. So 150 pounds cancels out on the left, and then 500 pounds minus 150, we might put that in math, so we can plug that in our handy-dandy calculator. We say 500 minus 150. And what do we get? We get Ray is 350 pounds. And so now we've solved for our reactionary forces, which is step 2. So, okay, Ray was 350 pounds, and that's going upward. And Ricky, we said, was 150 pounds, and that was also going upward. And so now we're ready to move on to step 3, which we'll see in the next video.